guys, Her Majesty took away my fear I had in chemistry and biology. You have to join the Easy World. My name is Vitrio Modia, a student in Italy. Anywhere you are, you can join us. Join the Easy World. Be a subscriber. Bye.
The whispers in the morning.
So the answer is A, yeah, according to this option, because of its high electronegativity. And remember, fluorine is the most electronegative element. We move straight to question number 28, saying is a calculation how many coulombs of electricity would liberate 1.08 grams of silver from a solution of silver salt. How many?
Hi, my name is Jordan and welcome to Her Majesty Easy World channel. This is the best channel you can get on YouTube. So make sure you like, comment and subscribe.
How many coulombs of electricity? We are into question number 28. Coulombs of electricity required to discharge silver, and the half cell equation for silver is silver plus E. Whenever you see plus, you add plus E to give you silver, and that means that 1 mole of electron is required to discharge 1 mole of silver. Then 1 mole of electron will be discharged by 1 Faraday. So 1 E is equal to 1 F. 2 E is also equal to 2 F. Then convert this to mass. Molar mass of silver is given to us there in bracket as 108. So therefore, 1 Faraday in bracket was given. Hello, this is Her Majesty Easy World Science Channel, the Easy World of Science. Today, we will take a look at WAEC Chemistry past question 2021. Is a kind of a preparation for you to face this 2022 WAEC chemistry examination. So let us solve the objective question starting from number 1. So let's be as fast as possible. Number 1 question here says, as you can see there on the screen, says the hydrolysis of protein by dilute mineral acids produces A, sucrose, B, glucose, C, amino acid, D, fatty acid. The answer is C, amino acids. This is a kind of digestion of protein. Remember, the end product of digestion of protein is amino acids, and protein digestion is all about hydrolysis. In our body, there is the enzymes carry out the hydrolysis, of course, but if you subject protein in the presence of mineral acid, they become hydrolyzed. Even under alkalis, they can also be hydrolyzed. So which of the following oxides, that's number 2, causes acid rain? The secret to answer this is to look for any acid anhydride. And remember, acid anhydrides are actually oxides of non-metals that forms acid when they dissolve in water. And the only acid anhydride we have there in the option is D, which is NO2, that is nitrogen 4 oxide. It's a double acid anhydride and is a reddish brown gas. When dissolved in water, it will likely form an acid, HNO3 or HNO2, and that will lead to acid rain. Then option A, carbon 2 oxide, is a neutral oxide, therefore it cannot cause acid rain. Option B is nitrogen 2 oxide, is a neutral oxide also, it cannot cause acid rain. Hydrogen peroxide is a neutral liquid, volatile liquid when concentrated, but cannot cause acid rain. The next question is calculation. They say the ratio of carbon atoms to hydrogen atoms in a hydrocarbon is 1:2. If its molecular mass is 56, what is the molecular formula? So what we're going to do here for question number 3, we are looking at question number 3. The ratio of carbon to hydrogen is 1:2, which means the empirical formula is C1H2. Then remember, empirical formula bracket N is equal to molar mass, which is 56, given already. Therefore, carbon is 12. Remember, that's the molar mass of carbon. We now say 12 plus hydrogen is 1 times 2. 1 times 2, which is 2, bracket N equal to 56, such that 12 plus 2 is 14N equal to 56, such that N is equal to 56 divided by 14, and N is equal to 4. Of course, then you go back here and place your N as 4. And if we do that, what do we have? We have that this is CH2 bracket 4. So expanding, 4 times 1 is C4, 4 times 2 is H8. So the molecular formula is C4H8. That is it for question number 3. So we move to question number 4, and there is a structure there. Okay, this structure here, they have it there. They say, what is the relative molecular mass of the compound below. Okay, this structure, that's what we are told to find the molar mass. Remember that here is actually a phenyl, that's phenyl, a benzene that lacks one hydrogen. This should be C6, that is 1, 2, 3, 4, 5, 6, then H5. There is no more H here because of this carbon attachment to it. So this now, you can find the molar mass of this, then find the molar mass of this one separately. Carbon here is 12 times 6 plus 5. So what we have is 77. So for phenyl is 77. Then plus, this is actually COO, which is 12 plus oxygen is 16. 16 times 2 is 32 because we have 2 atoms of oxygen, 1, 2. So we have 32 here. Then plus, this is a methyl group, which is 12 plus 3, giving us 15. So on the total, we have 77 plus 12 plus 32 plus 15, which will give you 136. So the answer is 136, which is option B, 136. So if you are not careful, you might get 137. That's A. If you don't exclude this one, if you go and write C6H6, remember the hydrogen that's supposed to be here has been substituted. So the answer is B. Then cathode protection of metals, that's question number 5. Cathode protection of metal. Okay. So number 5 says cathode protection of metals is based on, okay, this is simple. It's based on A, standard electrode potential of hydrogen. Not really for hydrogen because that of hydrogen is 0. Based on its electrical conductivity. No. Nature of oxides, not really. Relative tendencies of oxidation, yes, relative tendencies of oxidation. When we say cathodic protection of metal, is a kind of sacrificial anodizing, in the sense that the metal to be protected by another metal is made the cathode of a cell. So in that case, you use a metal that have a more tendency of oxidation to coat another metal. For example, you use zinc to coat iron. In that case, zinc have more tendency of undergoing oxidation than iron because zinc is more reactive. So the answer is D. The number C says if humid air is polluted by chlorine discharge, the air can be restored by sprinkling. You see there on the screen. This is just based on the fact that we will use our discretion. Chlorine is a powerful oxidizing agent, and option A says solid manganese 2. You can't even sprinkle that because it's solid. Manganese 2 is oxidizing, so oxidizing versus oxidizing will not neutralize. Acidified KMnO4 still oxidizing. Acidified iron 2 sulfate is a reducing agent. Then sodium, saturated sodium chloride is neutral. So the answer should be C, that is acidified iron 2 sulfate, based on the idea of redox reaction, because the iron 2 sulfate will be oxidized to iron 3 by the chlorine, and iron 2 sulfate is a strong reducing agent and will reduce actually the resulting chlorine to a harmless form. Then question number 7 says the alkanol represented by the structure below is, you see the structure there. So this structure, that's question 7, they are asking us if the alkanol is represented is what? Primary and dihydric, secondary and monohydric, tertiary and dihydric, secondary and dihydric. From the illustration, when the OH occur at the extreme, at the end of the chain, this is the OH, this is OH, which makes it primary. With regard to this OH here, this alkanol is primary, then this OH here is primary because this carbon bearing OH is having only one alkyl. The same carbon here bearing OH is having only one alkyl. So primary is denoted with this when you have something like this. So if you have 2 hydrogens attached to the carbon atom bearing the OH is primary. and see it here, there are 2 hydrogens attached to the carbon bearing the OH, so that makes it primary. Then it's obvious that this is primary. Then it has 2 OH. When a given alkanol has 2 OH, you refer to it as dihydric, but when it has 1 OH, you say monohydric. Monohydric. When there is only 1 OH, such thing like this. This is primary and monohydric because there is only 1 OH and is attached at the end. But this one has OH, so option A is the answer. It is actually primary and dihydric. What makes it dihydric? 2 OH groups. Then what makes it primary? The OH is at the end of the chain in each case, and there are 2 hydrogens attached. But if the OH is here, there will only be 1 hydrogen attached, and that makes it secondary. So when there is no OH at all to the carbon, when there is no hydrogen at all to the carbon bearing the OH, that is the alpha carbon, you call it tertiary. Okay? So, but when the OH is at the terminal, at the end of the chain, it is forming primary alkanol. Then the next question says, which of the following pairs of compounds would form a precipitate when their aqueous solutions are mixed? They are asking us question based on double decomposition. Option A says sodium chloride and potassium trioxonitrate 5. No. B says potassium chloride and sodium trioxonitrate 5. No, both of them are soluble and the compounds of mixing them are also soluble. Potassium sulfate and barium chloride. Yes, that is a typical double decomposition. If you mix K2SO4 with barium chloride, in fact, this is how to detect SO4 in the laboratory. It will form an insoluble sulfate of barium tetraoxosulfate 6 plus potassium chloride, of course. So this is solid, which is giving us white precipitate, and this is aqueous. This is a typical example of double decomposition. So there will be a precipitate here, and it is white PPT. So that's how to test for sulfates, tetraoxosulfate 6 ion in the laboratory. Okay, then you see the answers to the graph. I don't have time there, 9, 10, and 11, so I jump straight to number 12. The formation of ethene from the dehydration of ethanol can be described as, when ethene is formed from ethanol, it is actually dehydration, and in dehydration reaction, there is elimination of water molecules. Therefore, we can take the answer to be elimination reaction. So what's that number? Okay, I jumped straight to number 12. Okay, we say the formation of ethene from ethanol. This is ethanol, C2H5OH. Then if you treat it with conc H2SO4, it will remove 1 water molecule. That's elimination. Remember how many hydrogen do we have here? 5 plus 1, which is 6. And 6 minus 2 will give you 4. So we have C2 because it's not touched. Instead of H6, we now have H4, and the only oxygen here has been removed. So at the end, this is what we call dehydration reaction. But according to the option, dehydration means elimination. That is to eliminate. Removing 1 water molecule from ethanol gives us what? Ethene, and that is it on the board. So the answer to that question is option B, elimination reaction. Then it cannot be oxidation because rather you have removed oxygen either and equally removed the hydrogen more. Okay, look up. Okay. Formation of ethene from the dehydration of ethanol can be described as, is it an oxidation reaction? Probably. It should be elimination reaction. Okay, which of the following, that's number 13, which of the following gases is highly soluble in water at room temperature? Ammonia is very much soluble in water, such that about 90 grams of ammonia can dissolve in 100 milliliters of water at room temperature, and that's why ammonia is also suitable for carrying out a fountain experiment. You can watch my video here on this channel on fountain experiment, the 10 best fountain experiments using ammonia gas, HCl, and SO2. Of course, with many colors and entertaining. Then carbon dioxide is soluble but not extremely soluble. Chlorine dissolves but not well. Nitrogen doesn't dissolve well in water at all. So nitrogen gas is insoluble. Then number 14 says a molecule of phosphorus is a molecule of phosphorus is a tetraatomic molecule. Phosphorus occur in form of P4, as you can see there on the screen. Then one should also know that sulfur is an S8, that's octaatomic, tetraatomic. Oxygen is diatomic, nitrogen diatomic, hydrogen diatomic. But this phosphorus molecule is a tetraatomic molecule, which is option C. Then question 15 says the most common method of preparing insoluble salts is by, as we just demonstrated in question number 8, of course, you prepare it by double decomposition, which is option D. In double decomposition, you are required to bring 2 soluble samples. In double decomposition, it involves the reaction of 2 soluble aqueous compounds to produce 1 insoluble or volatile or gas with 1 soluble compound. So in that case, any soluble salt, like you saw in barium sulfate, I will use that number 8 to demonstrate again. Potassium tetraoxosulfate 6 is aqueous, which means it's soluble, plus barium chloride, which is also soluble. Then in this case, there will be exchange of radical. That is, this SO4 comes to this barium, whereas Cl comes to potassium. In that case, it becomes potassium chloride, which is aqueous, meaning soluble, plus an insoluble barium sulfate. This is solid. So in that case, we have soluble mixing 2 soluble to give us 1 soluble as a product and 1 insoluble. So if you want to prepare barium sulfate in the laboratory, you use it this way. Then you can easily recover it by filtration. Then the next question says, that should be question number 16. The number of moles of oxygen would exert a pressure of, what number of moles of oxygen would exert a pressure of 10 atm at 320 Kelvin in an 8.2 dm cube cylinder? So they have given us volume, pressure, temperature, then they are asking us for mole. We use equation of state, that is ideal gas equation. Equation of state is the thing to be used here. That is the gas equation that connects 4 parameters of gases. That is, it connects mole, pressure, temperature, and volume. So using ideal gas equation, we have that PV is equals nRT. They give us pressure and it is in accepted unit. Pressure must be in atm. So this is 10 times volume must be in dm cube. They gave it to us 8.2 is equal to n. That's what we are looking for. They say what number of mole times gas constant in brackets. Gas constant is given, which is 0.082. Then times T, the temperature was given in Kelvin, 320. Remember, if the temperature is not in Kelvin, you must convert to Kelvin. If the volume is not in dm cube, you convert to dm cube. Then if the pressure is not in atm, you convert to atm because of that gas constant, which is gotten by R equal to 0.082 atm dm cube per mole per Kelvin. So to make it rhyme. Now, from the calculator department, what we have now is 10 times 8.2 should be 82, of course. 10 times 8.2 is going to give us 82, which is equal to 0.082 times 320, give us 26.24. So this is 22.24 n, such that n is divide both sides by 26.24. 26.24 cancel. Our n is now 82 divided by, which will give you 3.125, approximately 3.13, which is option C. That's the correct answer for question number 16. Okay, question 17 says the basic property of salts used as drying agents is A, efflorescent. No, that should be a wetting agent, of course, because it will lose its water of crystallization and get whatever around them wet. B says high melting point. No, hygroscopy. Very correct. It is C. So the basic property of salts used as drying agents is that they are hygroscopic. That's the best drying agent. And question 18 says, what would be observed when aqueous ammonia is added in drops and then in excess to a solution of copper 2 ions? If you add aqueous ammonia to a solution of copper 2 ions, there will be formation of a blue precipitate in drops, a light blue precipitate in drops, which dissolves in excess to form a deep blue solution. So option A says, blue precipitate is formed, which is soluble in excess ammonia. Yes, let's check if you have a better option. Brick red, no, that's B. White precipitate, never, not for copper. Then dirty, say green, D says green precipitate, no. Note this, copper is Chelsea for you that love Chelsea fan, that's the blue. So copper 2 ion is blue in the presence of aqueous ammonia and equally aqueous soda dioxide, but it dissolves. So the answer is option A. Then question 19 says, when copper 2 tetraoxosulfate 6 aqueous is added to lead 2 triazonitrate, the 2000 5 aqueous, this is still double the composition reaction that we did. There will be a white precipitate of lead 2 sulfate. Remember, almost all the sulfates are soluble in water except that of barium sulfate and lead 2 sulfate. Barium and lead 2, they are outstanding insoluble sulfates. So if you have copper 2 tetraoxosulfate 6 plus lead 2 triazonitrate 5, of course, there will be an exchange of radicals, meaning this NO3 comes to copper to give us Cu bracket NO3, and this is aqueous, soluble, whereby the SO4 goes to the lead, giving you lead 2 tetraoxosulfate 6, which is insoluble. So, and lead 2 tetraoxosulfate 6 precipitate is white. The answer is D. White precipitate will be formed. That's for question 19. Then number 20 says, consider the structure below. The structure below. Okay, let me draw. The structure is C2H5, C, H, and H. Then H is here. C, a carbonyl group. Then OH. Then the question says, how many carbon atoms does the parent chain have? The parent chain must contain the principal functional group, which this C double bond OO, that's carboxylic group actually. So it is going to be, this is carbon 2. This is 2 atoms already, so 3, 4. So don't be deceived by counting 1, 2, 3. So the parent chain has 4. So the answer is B, which is, this is 2, 3, 4. Okay. Then next question, which is question number 21, says, under which conditions of pressure and temperature would the volume of an inflated balloon increase? Under what condition will the volume of a gas increase? We are going to combine the idea of Charles' law and Boyle's law. According to Boyle's law, volume will automatically increase if the pressure decreases. So we have gotten that one. For volume to increase, according to Boyle's law, pressure must be decreased. That is inverse proportion. Then according to Charles' law, for volume to increase, temperature must also increase. So increase in temperature of a gas will automatically lead to increase in pressure. Will automatically lead to increase in volume. So what do we have? For volume of a gas, for volume of the balloon inflated to increase, the pressure must be reduced and the temperature must be increased. So looking at the option, they say both T and P are increased. No. Both T and P are decreased. No. C says T is increased, yes, and P is decreased. So option C is correct. That's temperature is increased and pressure is decreased in order for the volume to increase. Now, number 22 says the collision between ideal gas molecules are considered to be perfectly elastic because A, they collide without losing energy. Of course, their individual energies may change, of course, but the sum total of their energy remains constant, which means the sum of their individual energy before and after collision remains equal. There is no energy lost on the net calculations. They move randomly in a straight line. Not really. The average kinetic energy is variable. Yes, the average kinetic energy, no, the average is not variable. The distance between them is large, so the answer should be A. elements with, that's 23, says the elements with high ionization energy would lose electron easily. Ionization energy is the energy required to remove an electron from an atom, or rather to remove the most loosely bound electron from an atom, if you talk about the first ionization energy. So in that aspect, looking at this, when an element has high ionization energy, it will lose electron easily. No, if it loses electron easily, it means it has low ionization energy. It means you can easily remove it. B says have large atomic radii. If it has a large atomic radii, it means that there will be less nuclear pool on the last shell, which makes the ionization energy low and not high. So the higher the atomic size, the lower the ionization energy. And what determines atomic size is atomic radius. So option A and B is supporting elements that have low ionization energy instead, and not elements with high ionization energy. Option C says have high effective nuclear charges. Yes, of course. When there is high effective nuclear charges, meaning when there are more nuclear charges pulling on the outermost shell electron, the ionization energy is going to be automatically high. Option D says have low atomic number. No. So C, elements with high ionization energy would have high effective nuclear charge. Remember, there are about 4 or 3 factors that affect the ionization energy of a given atom. First is the atomic radius or the atomic size. If you listen where I've explained it. Then second is the screening effect of the inner shear electrons. Then the third one is the size of the nuclear charge, or the nuclear pool or effective nuclear charge, or nuclear pool on the last shell. The fourth one may be for higher level, the type of electron involved, of course. That is, if the electron being removed is in S, it's going to be easier to remove electron from the S orbital than to remove from P, and then to remove from D and F. So remember, these are sub-energy levels, of course. That is why you see that elements in the P block have lower ionization energy than elements in the D block, even though we say ionization energy automatically increases across the period. But when you look at, we have to pass through D before P. But unfortunately, the ionization energy of elements in the P block automatically is lower than the elements in the D block, because of the fact that D orbital is of higher energy level than P orbital. So you can use SPDF, of course. That should be for the last factor. Now, it is that factor that the knowledge of that factor is what we use to answer this question. So when there is more atomic radius, when an atom is large in size, it will have a lower ionization energy. But when an atom have more inner shells, it will also have lower ionization energy. Then when an atom have more effective nuclear pool, the ionization energy will be likely high, and this is why the ionization energy of calcium is more than that of potassium. Because of what? Calcium have 20 nuclear charges pulling on the electrons. Out of that, 22 is acting on the last shell. And remember, in chemistry, electrons are only removed from the last shell during chemical reactions. For electrons to be removed in inner shells, you have to do with bombarding, maybe tungsten, all these ones. This should be nuclear aspects. You are no longer carrying out normal chemical reaction. So then, if you take a look at that of potassium. Potassium have 19 protons, out of which one is only pulling the last shell. So it becomes easier for you to remove an electron from the potassium atom, making potassium have lower ionization energy than calcium, because there is only one nuclear pool on the last shell of potassium, but there are 2 nuclear pools on the last shell of calcium, because the 2 electrons in the last shell of calcium is held tight also by 2 protons in the nucleus. So that is it. The charge in calcium is more than the charge in potassium in terms of the nucleus. Okay. Then we move to the next question, which says number 24. Which of the following statements about group 7 elements is correct? They are present in the same physical state. No, at least the first 2 are gases at room temperature, meaning fluorine, chlorine are gases, while iodine is a solid volatile, bromine is also liquid, then astatine is of course a solid. So they are not the same. They are not present in the same physical state. B says they are strong reducing agents. Never. They are never strong reducing agents. Rather, they are the most powerful oxidizing agents we have. Fluorine is the most electronegative and therefore is also likely to be the most powerful oxidizing. So C says their reactivity decreases down the group. Of course, the reactivity of the halogens decreases down the group. So you can use this acronym. I'm a football fan and I love football. Not really, I don't play, but I love football. I'm a football fan. I love Football Club Barcelona International. So FCB, you can use this FCB. That's our acronym for the halogens. You can now call it FCBIA, meaning fluorine, chlorine, bromine, iodine, astatine, FCBIA. Football Club Barcelona, but here fluorine, chlorine, bromine. Therefore, you see that fluorine is most reactive, followed by chlorine, then bromine, and finally iodine. So you can say that their reactivity decreases down the group, which makes fluorine the most reactive halogen. In fact, the most reactive element in general should be fluorine. So their reactivity decreases down the group. That is question 24. Option C is correct. Then question 25, as you can see there, I'll have to draw the structure.
Hi, my name is Cheryl.
And I'm Jennifer.
Guess what? There's a channel called Her Majesty Easy World Science.
And do you know the best part?
Mm-hmm.
It makes science so easy. Wow.
It makes science easy, simplified, and very, very fun.
Guess what? Rocket science ain't rocket science anymore.
It's now ABC.
Like if you did science your entire life.
Another thing about Her Majesty Easy World Science channel is that he makes available laboratory equipment and reagents.
Guess the best part? If chemistry has been hard for you, he does tutorials.
And another thing is when you order for these things, they are high quality and they are also cheap and affordable for anybody.
If you want to order, just look at the number below the screen.
And don't forget to subscribe and hit the little notification button down below.
Don't forget to share, of course, obviously there's love in sharing.
Thank you! See you there.
Okay, you see the structure there, that should be for question 25 and 26. This is a half cell. This is an electrochemical cell having two half cells, and it's obvious showing us this is the arrow for electron, movement of electron. Then we have that which of the following cell notations represents the diagram. In cell notation we use a metal ion metal system. Yes, of course, the metal ion metal system representation is okay. So the metal ion metal system, meaning this is the ion, that's Al3/metal. So versus the same thing here slash the ion. So looking at the option, the nearest correct one should be option B. That's describing these half cells correctly. The metal ion metal system and the metal ion system, of course. Then which of the following, meaning the ion is the aqueous while the metal is the electrode. So it's option B. Like in your Daniel cell is made up of the zinc ion zinc metal system, then made up of a copper metal copper ion half cell. So this is the way, this is a half cell, this is a half cell, and this slash is just showing about a salt bridge connecting them here. Okay, so then the next question says which of the following, that's question 26, which of the following half reaction equation represents the reaction at the cathode? At the cathode, looking at this setup, remember, usually I want you to know something now. You can use the term AC. Say AC. Yeah, I guess you have said that. AC means a condition, but now our AC is going to stand from anode to cathode. Anode to cathode, meaning electron move from anode to cathode. So since this arrow is pointing from this particular half cell to this particular half cell, it means that this was automatically our anode, and this half cell is automatically our cathode because of this electron. Electron moves from anode to cathode in whichever case, whether you are talking about electrochemical cell, electrolytic cell, the direction of movement of electron is AC, that's a condition, but here it means anode to cathode. So now they ask us, the question 26 says, which of the following half reaction equations represents the reaction at the cathode? So we are looking at the reaction here, At the cathode, when the electron comes here, it means that this B, remember, the type of reaction happening at the cathode is reduction, while the type of reaction happening at the anode is oxidation, irrespective of whether it's an electrolytic cell or if it is an electrochemical cell. But anode is the electrode where oxidation takes place, whereas cathode is the electrode where reduction takes place. So, and here they are asking us the equation of the reaction taking place in this particular compartment, which is the cathode compartment. And being a cathode is automatically reduction, and being a reduction shows that there will be gain of electrons. Say RIG. This acronym RIG means reduction involves gain. Reduction involves gain of electron. That means reduction reaction, you have to add electron. That means when this electron, the equation is simple. This is the ion remaining, B plus. This electron, when it arrives here, it will accept the two electrons to become reduced to B. So this should be the equation happening at the cathode. This is reduction. This is electron. So when it is 2 plus, it will gain 2 electrons to become reduced. And that is option, looking at it well, that's option B still. So option B is the correct answer to question number 26. Then number 27 says the reactivity of fluorine is high because A is high because of its high electronegativity. Yeah, that's likely going to be answer, but let's look at the options, other options. Remember to look at other options properly so that you won't fail due to overconfidence. So you calm down. They say B says the small size of the fluorine atom. No, small size is not the reason. Then they said the availability of the d orbital. If small size is the reason why it's very reactive, you know that helium, which is the smallest size atom, would have been the most reactive. So B is not correct. C says the availability of d orbitals. No, there is no d orbital in fluorine. It's not a d block element. Then D says the strong fluorine to fluorine covalent bond. No. So the answer is A, yeah, according to this option, because of its high electronegativity. And remember, fluorine is the most electronegative element. We move straight to question number 28, saying is a calculation how many coulombs of electricity would liberate 1.08 grams of silver from a solution of silver salt. How many?
Hi, my name is Jordan, and welcome to Sir Majesty Easy World channel. This is the best channel you can get on YouTube. So make sure you like, comment, and subscribe.
How many coulombs of electricity? We are into question number 28. Coulombs of electricity required to discharge silver, and the half cell equation for silver is silver plus E. Whenever you see plus, you add plus E to give you silver, and that means that 1 mole of electron is required to discharge 1 mole of silver. Then 1 mole of electron will be discharged by 1 Faraday. So 1 E is equal to 1 F. 2 E is also equal to 2 F. Then convert this to mass. Molar mass of silver is given to us there in bracket as 108. So therefore, 1 Faraday in bracket was given is 96,500 will discharge 108. Then X will be discharged. What quantity will discharge 1.08? Here you don't need your calculator. I want to teach you a cheat. You can watch one of my videos here, shortcuts to chemistry calculation. Watch, this is 108, 108. The difference is the position of the point. I hope you know that 1 means 1.0. So 108 means 108.0. So the difference between these two numbers is the position of the point. So here, if you move this point 1, 2, you get here. So this means that this point was shifted 2 places behind to get this. So when you come here, you also shift this point here, because 96,500 ended with a point. You shift it 1, 2. So my answer is automatically 965, because it's a point shift. It's a cheat. But if you don't understand, you just cross multiply as usual. What will it be? 108x is equal to 1.08 times 96,500. So the calculator department, you have here that 1.08 times 96500 is equal to actually 104,220. Then x, meaning divide by 108, which will give you 965 coulombs. So that's the answer. But I've taught you how to get it even without pressing your calculator. Shifting of points. If point was shifted 2 places behind here, I'll come here and shift it also behind 2 places. 1, 2. Meaning 108 gave me 96,500. What will 1.08 give me? 1.08 will give me automatically shift the point towards. This is only applicable when they are of the same digit but having different positions for the points. Okay. Then the next question number 29. So the answer to number 28 is C, 965 coulombs. The Bohr model 29 says the Bohr model of the atom proposed the existence of A, the nucleus. No, it is the Rutherford model. It was Rutherford that discovered the nucleus through the experiment of his 2 students, Gige and Macedon. And I'm believing to discover something from you that is my follower. And don't forget to subscribe and share this video. And there is opportunity for you to get me involved in your private lessons, of course. I will give you the assurance in any exam you're preparing concerning chemistry, biology, and medical related courses. Her Majesty is here. Yes, of course, with little token you will do well with Her Majesty. And again, don't forget, please, to expand this science community. We need your support. We have many things to keep this our studio functional enough to serve you best. So the much you can do for us, we need your support financially. Even get a nice camera and equally build our electronic board, the gadgets we have been using electronically for this class. If you watch my last video where I did this on the WAEC Chemistry, it wasn't like this. I was using a very nice iPad with an electronic board. It's no more. You can still help us get one. God bless you as you do this. Her Majesty's World Science Channel is nowhere without you. I'm so much impressed that someone like you is there for me. But remember, together we stand, divided we fall. I wouldn't be here if not you. Keep pushing. Let's keep pushing till we get there. God bless you. So, back to what I was saying. The person that discovered actually the nucleus should be Rutherford from the Gige and Macedon alpha scattering experiment. So that of Bohr electron shells, of course. It was Bohr that told us the angular momentum of the orbiting electrons are quantized. It was his model that explained why atoms do not collapse. Of course, there is much credit to Bohr's explanation, but he first started by saying that Rutherford is basically correct. But Rutherford's model could not explain why atoms do not collapse. Because from his explanation, the negatively charged, I'm talking about Rutherford, the negatively charged electron will just move into the positively charged nucleus and actually it will disappear. But he told us that the electrons are not just freely moving like cloud of electron as predicted by Rutherford model. No, he told us that they are moving in a specific orbit called energy level. So he's the one that introduced these shells we are making use of today. That's Bohr. So option B is very, very correct for Bohr, and much credit to him. Okay, question 30 says at 25 degrees Celsius, evaporation of 100 cm³ solution of K2CO3 to dryness gave 14 grams of the salt. What is the solubility of K2CO3, that is potassium triiodocarbonate, for at 25 degrees, giving us the molar mass of K2CO3 as 138. You can watch my video here on solubility made easy, of course. You know this is Easy World Science Channel and we are here to make things easy for you. If you watch that video on solubility and some other videos here, you will not see chemistry as a difficult subject again. You see chemistry as a subject that you do and smile, because Her Majesty's Easy World is here for you. Remember to look up for other tutorials here on this channel. Okay, then I'm trying to tell you, maybe I'll solve straight without using that cheat. It's now left for you. If you want a shortcut, you go and watch that my video on solubility. But here I'm going to solve normal. First, if not in 1000, find out the one in 1000. They told us on evaporation of 100 cm³. So 100 cm³ of the solution were able to contain were able to give us 14 grams of the salt. 14 grams. So if 100 contain 14 grams, what will 1000 contain? You call it X. And this is, you can now get the answer without even calculator. This is still multiplication factor 100. How many times will you multiply this 100 to get 1000, which is times 10? 100 times 10 is 1000. So X will also be 14 times 10, which is 140. So X is automatically 140 by my cheat in what I call multiplication factor. So watch down my video, shortcuts on chemistry. You'll be happy with yourself, and you will never forget our channel again. But let's cross multiply. 100x is equal to 1000 times 14. So we have that 1000 times 14 should be 14,000, of course. So that x alone is equal to 14,000 divided by 100. At the end, you have that same 140 I've arrived at. This is 140 gram per dm cube, because dm cube means 1000 cm cube. But they said in mole per dm cube. Therefore, you divide by the molar mass of the salt sample. And molar mass of the salt provided for us is 138. So that makes job easy for us. So 140 divided by 138, which will give you approximately 1. So we have option C is going to be the answer. That is 1.01 mole per dm cube. So that is it for question 30. Now stay subscribed to see other further solvings for this WAEC 2021, getting you prepared for this 2022. God bless you. Goodbye for now.
The whispers in the morning.
I love you. Thank you for watching.
And